focus for today is going to take all of the skills that we've been working on this unit with addition and subtraction of fractions and addition and subtraction of mixed numbers and apply those skills to be able to solve problems. So your focus for today is I can solve problems by using the standard algorithm for adding and subtracting fractions and mixed numbers. So the first problem we're going to take a look at is your solve and share, and it says Annie found 3 seashells at the beach. How much shorter is the Scotch bonnet seashell than the combined length of the alphabet cone seashells? Solve this problem any way you choose. Use a diagram to help. So that keyword there, use a diagram to help, tells us that we are going to use a bar diagram to help us look for it. So the first thing we're going to do is we're going to break this problem apart. So she found 3 seashells at the beach. How much shorter is the Scotch bonnet seashell than the combined length of the 2 alphabet cones? So my first step that I'm going to do is I'm going to combine the length of the alphabet code. And so my total length, so if I put this in a bar diagram, my total length is going to be 1 3/4 added to 1 3/4. And so when I solve for the combined length, when I go ahead and add them together, I end up with 6/4. I'm coming up here because you can't see that. So I end up with 6/4, and then 1 added to 1 is going to be 2 6/4. So I need to turn that into a into a proper fraction. So 4 goes into 6 one time, so the 2 becomes a 3, and then I'm left with 2/4 left over, and then I need to see, can I simplify 2/4? The answer is yes. I can divide both 2 and 4 by 2, so my answer is going to be 3 1/2. So that's the first step. Okay, so if I draw my next bar diagram, what I'm going to do is I'm going to have my total. So I'm going to do a double bar diagram. So here my total is going to be 3 1/2. So when we did our 2 alphabet cone seashells, we ended up with 3 1/2. I'm going to solve for the missing value of length. So I'm just going to put L for length, and then the Scotch bonnet is going to be 2 1/8 inch. And so to solve for L, what I need to do, I have part whole, and I'm missing a part, so I'm going to subtract. So I'm going to do 3 1/2, subtract 2 1/8. Common denominator is going to be 8, so this becomes 4/8. This becomes 1/8. I take a look. Do I need to regroup? Nope. 4 is larger than 1. I don't need to regroup. So I end up with 3/8. And then 3 subtract 2 is going to be 1. So my length, or the difference between the length of the Scotch bonnet and 2 of the alphabet cones, is going to be 1 3/8 inches. Okay. So another way, it says, what is another way to represent this problem? So if I take it out of the diagram and I turn it into one large problem, what I'm looking for is I'm looking for my length. So I'm just going to say length is equal to 1 3/4 was the length of one of my Scotch bonnets plus 1 3/4. And then I'm going to take those and I'm going to subtract from there 2 1/8. And I don't need to put 1 3/4 plus 1 3/4 in parentheses. If you want to, you can. But when I do order of operations, addition is always going to come before subtraction if it comes first in the problem, which it did here. Okay, so that's another way that I could represent that problem. Length equals 1 3/4 plus 1 3/4 minus 2 1/8. So I can model with mathematics. If I go to that mathematical practice, we're focusing on model with math. I can model by doing a bar diagram or by creating equations with a variable. Okay, so let's take a look at your visual learning. And it says, how can you represent a problem with a bar diagram? And it says, the first step of a recipe is to mix the flour, white sugar, and brown sugar. Will a bowl that holds 4 cups be large enough? So if we take a look here, we're going to mix the flour, which is 1 3/4 cups, half a cup of brown sugar, and 1 1/4 cups white sugar. We need to see if I put all of those in there, if a bowl that's going to be 4 cups is going to be large enough. So if you look right here, we built a bar diagram. So the n cups needs to be less than 4. If the n cups is not less than 4, that 4-cup bowl will not be large enough. And so you'll see that n, here's my equation right here, n equals 1 3/4 plus 1/2 plus 1 1/4. So I'm going to go ahead, and if you'll notice what they did is they added all 3 at the same time. You are more than welcome to add all 3 at the same time, but if you need to break it apart into smaller, break it apart into smaller. And so let me just change my color here. We'll go dark blue. So if I set this up as a problem, if I do 1 3/4 added to 1 1/4, and the reason I did 1 3/4 added to 1 1/4 is they are already a common denominator. Their common denominator is a 4, so I don't need to change anything here. So then it becomes 3/4 added to 1/4, which is equal to 4/4. And then I have 1 plus 1 is equal to 2. So I have 2 4/4, or that's equal to 3, plus 3 plus 1/2 is going to be equal to 3 1/2. And so notice that I didn't have to do it here. Their problem that they took the 2/4 and they added it into the same, or created a common denominator. I did not do that because I added the fourths first, got a whole number, and then just added that half to the whole number. So sometimes it works to switch those numbers around. Remember that when you're adding, you can use that commutative property of addition to switch the add-ins to get to a number that you want. Okay. All right. So our answer for this one, if we go back to n cups would be equal to 3 1/2 cups. Remember to use that unit of measurement. They give you a unit of measurement problem, use a unit of measurement. All right, let's take a look at the convince me. How many more cups of ingredients could still fit in the bowl? Use a bar diagram to represent the equation. So it's asking for, if I've got, we'll go with that color. If I've got 3 1/2 cups, right, my total, okay, so I'm going to draw my bar diagram. I'm going to put my total on the bottom just because I ran out of room. My total is 4 cups. Okay, I already know that I have 3 1/2 cups. They're wanting to know how much more can I fit into that bowl. Well, if I did 4 subtract 3 1/2, remember, because I have total part, and I need my other part because it's part whole. So I have my whole. I'm subtracting one of my parts from that, and that will give me the other missing part is going to be equal to 1/2. So m is going to be equal to 1/2 cups more. So again, I'm using that bar diagram to be able to help me see how this problem is going to be, how this problem is going to look, and how I can set the problem up. Okay. All right, let's go ahead and take a look at our guided practice. So again, we're using that model with math. They are wanting us today, it says draw a diagram to represent the problem. They're wanting us to use those bar diagrams. The big skill that you need is, can you read and choose the correct bar diagram for the problem? Okay. Philip wants to run a total of 3 miles each day. Monday morning, he ran 1 7/8 miles. How many more miles does he still need to run? So he's already run 1 7/8 miles. We're going to look at how much more he needs to run for today. So I'm going to draw my bar diagram. Left room for the top this time. He is running a total of 3 miles. So that's my total. It's 3 miles. He has already run 1 7/8. And then you pick a value, pick a variable. I'm going to use m for miles or m for more. There's my bar diagram. So he has already run 1 7/8. He needs to run a total of 3 miles, and then that will give us the m. So it says write and solve an equation for this problem. How did you find the solution? So m, right, we're looking for that missing variable. M is going to be equal to 3 subtract 1 7/8. Okay, now we're going to solve it. So to solve it, we're going to subtract 3, or we're going to subtract 1 7/8 from 3. Okay, and so when I do this, what I'm going to do is I'm going to have 3 is, I'm going to turn into 2 8/8. Because again, remember we talked about in mixed numbers when we were subtracting, if I have a whole number and I'm subtracting a mixed number from it, I turn it into a mixed number where my numerator represents a whole. So I make the matching denominator and then make this represent a whole. So 8 subtract 7 is going to be 1/8. 2 subtract 1 is going to be 1. So m is going to equal to 1 and 1/8 more. So I'm going to pop back up to this problem number 2 really quick and write and solve an equation for this problem. This is one way that we can write and solve an equation. The other way that you can write and solve an equation is where you put your total, so your 3 miles. So I'm going to have 3 on one side, and then I'm going to have my part on the other side. So I have 1 and 7/8 added to m. And then to solve this, we would set it up this way to where we would subtract 1 and 7/8 from 3. Okay, so taking a look at what you have for your problems, it's word problem work where you guys are doing bar diagrams. So you are going to go ahead and do 4, 5, and 6 because it's all related to this. It's what we just did. Draw a diagram, write an equation, solve the equation. What fraction computations did you do? So the fraction computations is, did you add, subtract, multiply, or divide? Well, you didn't multiply or divide because we're only adding subtraction. And then how many tons of pebbles did the landscaper use? You're giving the final answer down there. And then you're going to do the same thing on the back side. You're going to talk about using that 4 square. What do you need to know and what do you need to find? Okay. What quantities and operations will you use to find how much free time Roland had? So you're going to tell me how you're going to solve this. And then you're going to draw a diagram, use the equation, and solve. So you're going to go ahead and do 4 through 9 on your independent